In this screencast, we're going to learn how to find areas of parallelograms, triangles, and rhombuses. Okay, the first one is the area of a parallelogram, and it's the product of a base and the height to that base. Okay, so the base is this complete distance down here, or it could be up here, of course, and then the height is the perpendicular distance between the two bases. It's got to be perpendicular. Now, why is the area of a parallelogram formula the same as the area of a rectangle formula? Well, what if I took this rectangle right here and moved it? I'm going to pause this and I'm going to show you what happens. Okay, so what I've done is I've taken the triangle that was over here and I moved it over here, and guess what we created? We created a rectangle. So that's why the formula for the area of a parallelogram is the same as the formula for a rectangle. All right, now the area of a triangle equals half the product of a base and the height to that base. And why is that? Well, if I draw any random triangle, okay, I can always create a parallelogram out of that triangle. And since the area of a parallelogram is one base times the height, the area of a triangle is half the area of the parallelogram. Okay, so if we make this the base of the triangle, then this is going to be the perpendicular distance right there. All right. If I make this the base of the triangle, then I have to extend it out so I can draw a perpendicular distance that way. Okay. So it depends on which side is your base is going to determine what your altitude is of your triangle. So the area of a triangle is 1/2 base times height. The area of a rhombus is half the product of its diagonals. So if I call this diagonal D1 and I call this diagonal D2, then the area of that rhombus is 1/2 D1 times D2. And those diagonals, remember, are perpendicular to each other. Let's do some examples. So let's say we have an isosceles triangle with base 10 and perimeter of 36. Okay, so that means that it's going to look something like this. That's 10. Now each of these sides is x because it's isosceles. And so if the perimeter is 36 and part of that is 10, that means I have 26 left over. And so each side is going to be 13. That's going to be 26 plus 26 plus 10 gives me a perimeter of 36. Now how are we going to get the area? We don't know an altitude. Well, let's draw it straight down. Since it's isosceles, it will bisect the base. And so our altitude is going to be 12 because this is a 5, 12, 13 right triangle. Now we know enough to get the area. It's 1/2 the base times the height or the altitude, which is 5 times 12, which is 60. All right, let's try this one. Let's say we have an equilateral triangle with height 9. So now we know the height, but we don't know how long the base is along here, okay? Well, since it's equilateral, every angle is going to be 60, and this altitude, this height, is bisecting that angle, so it's 30. Hey, we've got our old friend, the 30, 60, 90 triangle. Now, this is the long leg of the right triangle because it's opposite 60, so stop that. Okay, so this is going to be 9 divided by root 3, which is 9 root 3 over 3, which is 3 root 3. So that's how much half the base is 3 root 3. And then this is going, we don't even need that. We have our base and we have our height. So here we go. Area is 1/2 base times height, Well, half the base is 3 root 3, right? And the height is 9, so our area is 27 root 3. All right, how about this one? We have a square inscribed in a circle of radius 10. So I'm going to draw my square here. Now the radius is not that, because a radius has to go from a center all the way out to the circle, so we can't use that, but we can draw it out that way. So that's 10, and that's also 10. Hey, a square is a special case of a rhombus, right? And so I'm going to use the 1/2 d1 d2, the rhombus area formula. Okay, each diagonal is 20, so this is half of 20 times 20, which is going to give us 200.